Hello students, after limits the next topic of calculus is derivatives. So we are going to discuss derivatives today. So let us first see what this derivative means. So here is the definition. Let f be a real valued function. Its derivative with respect to x is denoted by f dash x or dy dx and defined by this limit of x tends to 0 fx minus fx f of x plus h minus fx divided by h और इसमें कंडीशन है provided the limit exists. The limit has to exist because sometimes if this limit will not exist we will say that derivative doesn't exist. Okay, if this limit exists and whatever expression we get after evaluating this limit, that our previous topic, then whatever expression comes, that is called derivative of this function with respect to x. Alright, in fact this derivative that we have written today, this is also known as actually first order derivative. In class 12th we are going to get second order derivative as well. So the notation is not only f dash x or dy dx. Sometimes we use another notation like y1 or f1. These are also used to denote first order derivative that we are going to discuss today. Now let us see some illustrative examples. Before going to illustrative example, let me tell you one more thing. Evaluating derivative by using this formula is known as derivative by first principle. Actually, whenever we find out derivative by using this formula that we have written in terms of limit, then it is known as derivative by first principle. So whenever question comes, the question will come like this way. Using first principle, find the derivative of fx equal to x. We start with a very simple function. In fact, you might be remembering this is nothing but the identity function from chapter 2, relation and function. We know what is identity function, where input and output both are identical, right? Fx equal to x. If I write f1, the answer is also 1. f2, answer is 2. That means input output is same. That is known as identity function. So now we are going to differentiate this identity function with respect to x. In fact, this question here actually I missed out writing that with respect to x. It should have been there. What I mean to say, whenever we are going to come across questions of derivative, the question will come in this way. Using first principle, find the derivative of this function with respect to x. Okay. Our solution starts like this. We know that. After writing we know that, we should write down the formula, the first principle formula, f dash x equal to limit of x tends to 0 f of x plus h minus fx divided by h. Now we have to put the values. Limit of h tends to 0 f of x plus h, this value will be x plus h minus fx ka value is x, the entire thing is divided by h. I hope you understand this part. I am explaining again. See, fx equal to x. So in place of fx I have written x here. So this would imply f of x plus h would be equal to x plus h only. Because we are dealing with what? We are dealing with identity function. And in identity function, the input and output both are identical. So if fx equal to x, f of x plus h will be x plus h only. So I have replaced fx as x plus h. Now you see in the numerator, if I remove the bracket sign, what will be remaining? Only x plus h minus x upon h. Anything is getting cancelled? Yes, x is getting cancelled. So what is remaining? We are left with only limit of h tends to 0 h upon h. Okay. What is limit of h upon h? It is limit of 1. Limit of h tends to 0, h by h is 1. And from the previous topic limit, We know that limit of a constant is constant itself, so answer is 1. So what do you conclude? We conclude that key derivative of an identity function is equal to 1. That means as a conclusion we can write down, therefore dy dx, and what is why ddx of x is equal to 1. So this is actually the answer we represent in this way. The derivative of an identity function with respect to x is 1. I hope you are clear. Let us go to next example. Second example, we have taken that of a parabolic function, right? Fx equal to x square. That means y equal to x square. Y equal to x square is what kind of parabola? It is upward parabola. Y equal to x square. We have discussed in, I think, conic sections, right? So fx equal to x square, and beginning is same. What is the beginning? We know that, right? Beginning is we know that, and this beginning remains same in all the problems. F dash x equal to limit of x tends to 0, f of x plus h minus fx upon h. Now we have to put the individual values now. Okay, that means we should write down limit of h tends to 0, f of x plus h, its value will be x plus h whole square minus x square upon h. Alright, I hope you understand. This is functional value. You see, if fx equal to x square, f of x plus h will be equal to x plus h whole square. So this is equal to limit of h tends to 0, and you can write down this x plus h whole square ka formula, x square plus 2xh plus h square minus x square upon h. A plus b whole square formula I have applied for this a plus b whole square. Now what we see, this x square getting cancelled. What is left in the numerator? Numerator mein what is left? Limit of h tends to 0, 2xh plus h square by h. So if you divide individually, this h will divide the numerator, so we will be left with limit of h tends to 0, it will become 2x plus h, right? Now we have to go to previous topic, or topic of limit. What we see? Limit of h tends to 0, 2x plus h. If h is tending to 0, this expression will tend to, this is equal to 2x. Okay. So what is the conclusion? So we can conclude now, therefore ddx of x square is equal to 2x. Derivative of a parabolic function is actually 2x. ddx of x square is 2x. Okay. Third example. Predictably, I have taken the function fx equal to x cube. That is the simplest cubic function that we can come across. The first we have taken fx equal to x, second fx equal to x square, third fx equal to x cube, right? And beginning is always same. We know that fx equal to the usual the formula, and after this you put the values, and after this a plus b whole cube formula. Okay, you please put a plus b whole cube formula and go ahead, and you can write down in the comment section what is the answer to this derivative. Actually, as a first class on derivative, I have discussed intentionally very simple question, and it is a short video I wanted to make. And tomorrow in the next video I am going to upgrade the function now, because so far we are discussing with algebraic function only, and in the next video I will see some in algebra only, but some more terms will be there. Like so far we are dealing with only monomials, fx equal to x, x square, x cube, only one term there for monomial. So next in the coming videos, the complications of the function will little bit upgraded, and then we will see some more example. You please complete this question, and in the comment section you can write down what is the answer to this question. Thank you. Have a nice day.